Hi everyone, welcome to my video. This one's about how to measure voltage into a microprocessor, maybe like the Arduino Pro Mini as I'm going to be using. So, how to measure voltage. Now, the issue is that you may be wanting to measure something which might be, say, 24 volts. In my case, it would be 24 volts with the solar panel system because the batteries are 24 volts. So, you might be wanting to measure 24 volts, for example. Now, the issue is with the Arduino, and maybe some other ones, you can't actually input more than 5 volts into a pin. So, 5 volts max for the Arduino. Now, so you need a way of measuring 24 volts and putting it into an Arduino which has a maximum of 5 volts input. So what you have to do is scale this down to 5 volts maximum and then scale it back up, mathematically scale it back up. So the way to do this is as follows. We'd use a voltage divider. And this is how the voltage divider works. Right, I'll first draw it. There's a V in, then it goes down here to resistor 1, then let's move this piece of paper, then you get V out, and then you get resistor 2, and then ground. And that's basically the way the voltage divider works. So, what we need to do is we need to put 30 volts into V in. Well, 30 volts because, I'll just explain this, the maximum voltage that you'll be measuring, we think is 24, but you'd always go over, because when you scale this down, you need V out to be no greater than 5 volts. So you'd always put your maximum in here, and maybe add a little bit more. So I'm going to say, I want to measure 24 volts, I'm going to say 30. Right, now V out has got to be 5 volts max. Right, so the idea being the voltage comes in, it gets resisted proportionally, and this 5 volts max here will be a known proportion of that, so that when this gets read into the Arduino or whatever microprocessor you're using, you'll know the scale of how to scale this back up to 24 volts or 30 volts, whatever it is. So in this case, what we can do here is this. We've got this 30 volts here, we need 5 volts, so 30 volts divided by 5 is 6. And there are different ways of doing this, but this is the way I do it. So the ratio is, 30 volts divided by 5 is 6. So if there are, if we get 30 volts and split it into 6, we'll get 5. So there's 5, 5, 5, 5, 5, 5. And we want the voltage divider to divide the input voltage, which in this case is 30, by, into 6 parts, let's say. So we want one part, let's say the other way around. So we want 5 parts, which equals 25 volts, but that doesn't really matter at this stage. We want 5 volts to be resisted off, so we want R1 to resist that much off. Then we want R2 to resist that much off. Now, so if we look at the drawing again, in this example, R1 is going to resist off 25 volts, and R2 is going to resist off 5 volts. 25 and the 5 is 30 volts. So this should work in our case. So what we have to do now, we know the proportions. The ratio is 5 to 1. So 5 to 1, or depending on which way you want to do it, you can split it into 6 parts. So with this ratio 5 to 1, we can now use this to know what we want in resistor 1 and what we want in resistor 2. So, so let's say we have, well, let's keep this easy. Let's say we have 250 ohms, and we'll have 50 ohms here. Oops, boom. So what this should do, because it's the ratio that matters really, it's only the ratio that matters when it comes to the voltage divider, this should work. So what I'm going to do now, oh by the way, this splits the input voltage by that proportion of the ratio of those two. So I said that this 30 volts was max. Theoretically, it would be for 24 volts in our case. So 24 volts divided by 6, which is, let's see, 1, 2, 3, 4. Alright, 4 volts. 4 volts. So 24 volts divided by 6 is 4 volts. So what should happen here is that we'd have 5 times 4, which is 20 volts. So this will be 20 volts. And then the remainder will be 4 volts. So if we input 24 volts here, 20 volts will be resisted off by R1, and 4 volts will be resisted off by R2. So using this arrangement here, if we input 24 volts and we check the V out here, which is maximum of 5 volts, we'd be reading 4 volts. And that's the way this thing works. It's proportional to the input voltage. Right, so I'm going to demonstrate this now, and I'll explain more in a minute. Okay, I didn't have those exact values, so I'm going to do something different. Right, but it doesn't matter because the way it works is the same anyway. So this is what I've got. I've got 1 kilo ohm or 1k resistors. I've got lots of different ones, but for this I'm just going to use these. So I've got 1 kilo ohm resistors. So I'm going to have 3 of those, and I'm going to apply a voltage, let's say 10 volts. So this is what I'm going to do. So we've got V in, which is 10 volts. Then I'm going to have R1, which is going to be 1 kilo ohm, 1k. Then we're going to have V out. Right. And then we're going to have R2, 1k. And then we're going to have ground. Now, with these resistors, I said that I've got 3. What I'm going to do is, to make this thing a bit more interesting, I'm going to change that to 2 kilo ohm. So I'm going to have 2 kilo ohm there and 1 kilo ohm there. And I'm basically going to put 2 resistors in series. So instead of R1, R2, I'm going to have R1, which is going to represent 2 resistors. So I'm technically going to have R1, R2 and R3. But anyway, just to keep it simple, let's just group those together. So we've got R1, which is going to be 2 resistors, 2 1 kilo ohm resistors, which sums 2 kilo ohms. And we've got R2, which is 1 kilo ohm. So we've got 1 resistor, 2 resistors, V out, another resistor. So this is what I expect will happen. I'm going to give it 10 volts in, and now the proportions here, there are 3 parts. 2 parts are going to get resisted off here, and 1 part's going to get resisted off here. So of the 10 volts, there are 3 parts, so I divide 10 volts by 3, which is 3.33. This represents 2 parts, so I'd expect that to resist off 6.66 volts. That's what I'd expect, and I'd expect this resistor here to resist off 3.33 volts. And therefore V out should be 3.33 volts. So let's try this out. Okay. Right, so I'll plug this in. And 1 for ground. Right, do a zoom out a little bit really. Okay, now, first resistor from plus 5 volts, that's 1 kilo ohm. The next one, that's 2 kilo ohms. And next one is 3 kilo ohms. Well, technically it is, but right, let's see. So we've got 1 kilo ohm resisted, 2 kilo ohms of resistance, and I'm going to measure the voltage here, which is V out. So we've got red here, plus. So we're going to have 10 volts in. That's a 1 kilo ohm resistor, another kilo ohm resistor. Then I'm going to measure the voltage here, which is V out, and it's going to resist off another third, and then there's ground. So if I connect this up now, okay, turn this on, and connect this up, and ground. Connected that up. Right, now you can see here on my little power supply. Right. I'm going to change this voltage to 10 volts, as I said. Oops, 10 volts. We've got 10 volts there. Okay, now I get my multimeter. You can't really see it, but I've got to try and do this one-handed now. Right. There's the multimeter. Now if I put, just 1 second. Okay, so I've got ground connected there. And then what should happen here is it should resist off 2/3. So as in my calculations there, it should read 3 volts. And it reads 3.41, so that's good. So it's roughly resisted off 2/3, and we're getting 3.41, so that's really good. So you can see there, 10 volts, we've used the voltage divider to resist off 2/3, and the remaining third is reading 3.41 volts, so that's how we do it. So now, in the Arduino, this is what we do. I'll just turn this off. Turn this off. Okay, take this off. Take this off. Put that to one side for now. Right. So that's how we'd get a proportion of the 10 volts. Now, if I'd have put that down slightly to 9 volts, even there, if I'd have put that down to 9 volts, the clever thing is it would have put this down as a proportion. So then that would have been 6 volts, and this would have been 3 volts. So it's quite useful. So this is a voltage divider. Now, the relevance of this is that if we got this 10 volts or 30 volts or whatever example you want to go by, we've resisted it down now by a proportion, and we know that proportion. So in the Arduino now, for example, if we used, let's say this one to keep it simple. Let's say we give it 9 volts, 6 volts were resisted, and 3 volts came into the Arduino. So 3 volts into a pin on the Arduino. Now, because we can read that 3 volts came in, and we know the proportion of this here, we can easily work out what the voltage was. So all we have to do is multiply this by 3. So 3 multiplied by 3 is 9 volts. And that's all there is to it. So if this voltage here came into the Arduino at 2.5 volts, again, we know what it was as a proportion, so that's that multiplied by 3. So it's 7.5 volts. So we know that the input, so by looking at the output, 2.5, we know what the input voltage was, 7.5, because we know the relationship, or the ratio between the two resistors. So that's how we're going to do it, and that's how it works with the Arduino. So, right, the next steps are, when you feed in this voltage from the pin after the voltage divider here, this here, the voltage out, when that's read into the Arduino, we need something to happen. Basically, we need something called an ADC, analog to digital converter. Some microprocessors don't have one, but some do, and the Arduino Pro Mini does. So the ADC basically gets the analog value, which in this case here is 2.5 volts, or whatever. It gets that value and converts it to decimal. Not decimal, digital. So the Arduino Pro Mini has a 10-bit ADC, so 10 bits, and 2 to the power of 10 is 1024. So it would get this voltage here, 2.5 volts, and bearing in mind that 5 volts would be the full value, 5 volts would equal 1024 in digital, because the ADC converts it that way. 2.5 volts would be 512. And that's how the Arduino would read it in digitally. So after reading a pin, it would read 2.5 volts as 512. So that's it really. So you can do all the processing from that. So I'll show you how to do it in depth now on the Arduino. Okay. So time to create this this bit of code. We'll start with int value, and here we need serial.begin. Serial begin 9600, and in here value equals analog read A0. Analog read. Then serial dot println value. Okay, that looks about right. And then over here, just make the circuit. Okay. Put it that way actually. So move here, make the circuit. Set the camera up. So we need to turn this on. Set that to 10 volts, which it already is. Then here, wire this thing up. So that's wired up now. Okay. The Arduino. I'll put my Arduino in here. I'll add this thing. So there's my Arduino. Let's get that thing to focus. And I'm going to plug this into a 0, just this lead. Then plug this in here. A UART. Plug the UART in as well. Oh, I'll just have to move that over a bit. So plug the UART in here. Just give you a better angle. There we go, so you can see what's going on. Plug this into my laptop. Now, we need to plug this into here. Let's just double check this is right. It's right there. 10 volts. Plug that on in there. Okay, now, hopefully if we run the script it should work. We'll see. So, upload that. Upload compiling sketch. Uploading. Done uploading, right. And now you can see that it's coming out with some values. Just make this a bit smaller. Okay, you should be able to see. Is the camera okay? Yeah, you should be able to see what it's coming out with. Right. It's not actually coming out with anything meaningful at the minute. I know why. It's because of the ground on here. So the grounds have got to be tied. So I need to have a lead from the ground here to the ground on here, which I think is that one. I've noticed that this Arduino, for whatever reason, the ADC maxes out at around about 4.5 volts rather than 5 volts. That's kind of weird, but I don't know what's going on at the minute. So if I get my power supply, start to gradually put it up, you can see that the ADC reading's going up too. So for whatever reason, let's just go up to 1023, using the fine adjustment now. Yeah. Okay, it's 13.5 volts actually, so 13.5 divided by 3, 4.5 volts, yeah. So this thing, for some reason, this Arduino maxes out at 4.5 volts. Yeah, so what it means is 0 is 0 volts and 1023 is 4.5 volts. So that's good to know. So what we can do now is do some more code in here to convert that. So I'll just close this off. Save this. Okay, so we'll change the code slightly. So I'm going to have to type one-handed here because I've broke my camera stand. First of all, I need the calculator up. 4.5 volts divided by 1023. I'll copy that massive number and paste it here. Const int. Oh no. Float. Const float. Let's say voltage per point equals that huge number. Then over here, we need another one, another float. Voltage. And over here, voltage equals value multiplied by VPP. I should. Oh right, we need to print that. That should give us the voltage now. Let's just double check. Compiling sketch. Uploading. Done. Right. Right, so this is now giving us the voltage which is coming in to the Arduino via that Vout on the voltage divider. So I'll just double check this. And the voltmeter is saying 4.5 volts, and that's saying 4.5. So that's good. Now, if I reduce this the voltage should drop according to the resistors again, so it should be a third. So I'll drop this down to 10 volts, and then this voltage should now be 3.38. Okay, close enough. Over here, 3.38. The Arduino's getting this right. So now, right, this is the most important part, really. Now, the relationship between the resistors is quite simple. There's 2/3 resisted off, and there's 1/3 sent to the Arduino. So, with that formula, we should be able to make this quite easy. So, value multiplied by voltage per point multiplied by 3, because that's the relationship of the resistors. Upload. Uploading. Done uploading, right. Let's have a look at this thing again. Okay, so now it's reading. Oh, we're done here, by the way. 10.1 something. So now, if I change this, right, just show you again. 10.1 something. So okay, there's a tiny margin of error. One of this could be right, or this could be right. I don't know. So I'll reduce that. I'll keep reducing it, and you should be able to see it slowly creep down. So I'll reduce it to 6 volts. So you can see on here 6 volts, and on here 6.1. So okay, that's not bad. Right, so I'll keep going. So I'll change this down to let's say 2 volts. Oops. 2 volts. So now, let's see 2.09. And now I'll put this up to the maximum, but remember, at 4.5 volts, when this third resistor gets to 4.5 volts, then the Arduino stops sensing for whatever reason. So, and we've got to also remember that that's a third of a total value, or total voltage, sorry. So 4.5 multiplied by 3, 13.5. So okay, so 13.5. Done that again. 13. 13. Oops. 13.5. And 4.5 there, and here we see 4.5. Now if I go over this, this will accept 5 volts, but it just can't read it for whatever reason, so I can go a little bit higher actually, but I don't think that's going to work. So I'll go a bit higher. Let's say we should technically be able to go to 15 volts. Okay, so we've got 15 volts on there. So that's pretty easy. It's resisting off 10 volts, and it's giving 5 volts. 5 volts going into the Arduino, and we can double check there. 5.05, yeah, that's good. But you can see here, because its limit for whatever reason is 4.5, it doesn't sense it. It only senses up to that. So yeah, there's a bit of an issue there. But anyway, there we go. So we're measuring 15 volts. We're using a voltage divider to make it into a safe voltage for the Arduino. The Arduino is getting the value. It's using an ADC to make it digital. Then we've got a couple of calculations on here to get it from digital, in other words from 1024, back up to a voltage, and then we're displaying the voltage. The only issue with this is that it's being capped at 4.5 volts, which is unfortunate, but there we go, but it's working. And I'll just put this down to show you again. Put that down. 7.5 volts. Let's see. It's showing 7.6 volts. 7.5, there we go. And you should really be using capacitors as well, but I haven't used them. So there you go, that's how to measure voltage using an Arduino anyway. Thanks for watching, bye!